There is this simplistic and pessimistic notion that civilization is going down the drain. People will say things like, our society is going down the tubes. You've heard it before, from people disillusioned, from people embittered, from people who've practiced their cynicism and found they can get attention and nods of approval if they use such sloppy metaphors with almost defensive assurance. It's as though by describing their Cassandra visions of a dystopian collapse of all humanity has built over the past millennia, by using the analogy of fecal material flowing into an 18th to 20th century sewer system, they've somehow made the results of their fears incontrovertible. Have you asked yourself, however, about the relative strengths and weaknesses of our metaphors, and used systems thinking to probe their truths and falsehoods? What if we put nexus thinking into service in the analysis of the notion that we are going down the drain? What might happen? Let's explore. Let's explore this on its merits. What exactly is going down the drain, through the tubes, literally? Well, all of the undigested calories and proteins and fats and carbohydrates and macro and micronutrients that our bodies didn't assimilate after we ate our meals, certainly, along with an enormous amount of cellulose fibers that came from trees, cut down and unable to continue providing oxygen, carbon sequestration, and food and shelter just so we can wipe our butts. I'm talking about toilet paper. These things that literally are going down the drain are sad realities of our cradle-to-grave system of waste disposal, and I believe are things we can be ashamed about. But they're nothing to be overly pessimistic about. The nutrients and energy and materials have gone down the tubes, but they haven't gone away. The same goes for some of our food residuals. More than 50% of American households now have what were once called garbage disposals, now more popularly known as food waste grinders. Ironically, it's actually a good thing to put your food waste down the drain, if you want to contribute to society's efforts to be sustainable, that is. It turns out that when you grind up food and put it down the tubes, the huge amounts of extra energy and nutrients that the uneaten parts of plants and animals and your meals add to the slurry that's going to the waste treatment plant makes it economically efficient for the operators there to capture the methane and fertilizer that all water treatment plants produce and use them to generate electricity and hot water and soil amendment. But when all that goes down the drain is fecal material and toilet paper, the amounts of valuable outputs is reduced to the point where most operators don't bother to make use of them, so they simply flare off the methane and dump the sludge in landfill. But when food waste is added in, it helps them cross the tipping point from burden to bonanza. In this way, those parts of civilization that are literally going down the drain are recovered to help build an even better civilization. In a world designed through nexus thinking, going down the drain would not be a pejorative concept. It would be the conduit to healing the famous metabolic rift that Marx and Engels wrote about in the late 1800s. According to them, the current form of capitalism created a rift in the normal recycling processes that kept the metabolism of the biosphere functioning properly. Here's a good definition and explanation of the metabolic rift from Michael J. Lynch, University of South Florida. He says, quote, "The concept of metabolic rift is an extension of Marx's view on ecological crises that occur under capitalism associated with the development of that idea in the various works of John Bellamy Foster. It's a representation of the scientific and Marxist materialist analysis of the split between the human use and demand for energy under capitalism and how such demand and use destroys and creates imbalances in nature." Following Foster, the concept of the metabolic rift can be traced to the transfer of energy between rural and urban areas related especially to the use and manufacture of fertilizer products to enhance soils used to grow crops for export to urban centers. In addition, this idea also applies to the metabolic rift across nations and the transfer of metabolic energy from underdeveloped and developing nations to developed nations. The development of this idea is also related to Marx's theory of rent and its relationship to the development of the science of agricultural production. The metabolic rift that occurs in this case involves the transfer of nature's nutrients and hence the depletion of nature's resources in rural areas to produce food for the working class to facilitate its role in capitalist production. Foster, following Marx, suggests that after the emergence of agricultural sciences in the 1800s, The fertility of the soil in rural areas was no longer simply a product of the natural state of things, but was manipulated by the amendment of soils with fertilizers to increase productivity. This allowed a given quantity of land to produce more food resources than it would in its natural state. To increase productivity, soil was amended in various ways, both by the exploitation of natural fertilizer resources in dependent and colonized nations, and through the scientific creation of fertilizers. Foster's argument illustrates how processes such as industrial pollution in urban areas can also be related to the crisis of metabolic rift. To increase soil fertility, firms began to manufacture fertilizers, producing along with fertilizer extensive industrial waste. This waste stream, however, is not confined to urban locations, since the application of fertilizers in rural locations also promotes forms of land and water pollution associated with the application of fertilizers. Foster and his colleagues have also applied this idea to more complex analysis of international issues related to metabolic rift, including the transfer of energy across nations from soil through capitalist productive mechanisms to marine ecological issues, climate change, and other forms of material flow analysis. For a critique of some aspects of Foster's approach, see Moore 2000, 2008, and 2011.